You can see. Quite a lot of time we talked about the solid slab where you have your beam, you drop beam, sometimes you have your inverted beam, and sometimes you can even draw your internal beam very minimal that we have 150. You can see. But in this situation here, we're talking about a flat slab. Sometimes we have designs like this, but you know, I just decided to do a video concerning the finished work and the outwork. You can see. In so flat slab, what you do is to increase the thickness. You increase the thickness. I guess the minimum for that should be 10 inches. But I see a lot of people do 8 inches. But I advise anybody to go on that. You should go with 10 inches. 10 inches. And in flat slab, you're trying to reinforce your bar because design must go on. You're going to run your analysis, run your design, is going to give you what you ought to have. But in this, when you go to site, according to the design specification, you're going to reinforce it top and bottom. It's normally reinforced top and bottom. So after reinforcing top and bottom, we ought to have an internal beam running at the necessary area where we ought to have our beam. And the beam is run transversely. When I mean transversely, number one, we have a standing beam, just like the inverted beam. You can see there's a standing beam. But if you don't stand it vertically like this, we try to make it horizontally. You can see this is the horizontal version of it. Taking the same sheen with a well analyzed reinforcement and your stirrups. Pay attention to your stirrups because the function of a stirrups, like we all know as an engineer, that it helps to resist shearing in a beam. So we ought to add them where necessary according to the design specification. Don't just do it out of your design content. Don't just do it out of what you know. You understand? So in doing that, separating all the bars top and bottom, you can see there is need for we to add our horse bench. Horse bench, which is just a split. This is a splitter. Just going to split the top bar from the bottom bar so that they will not collide. So that there will be uniform, load. All the hopping moments and the sag moments will be taken care of. And the punching check. You have to split them. So it's nice we do that. So you can see. Just want to show us the flat slab for today. See. So after this, we'll go on the design to show you the design, how it ought to be on the design. But take note that this is just the outer look of the presentation on site. From your formwork, you can see the biscuits they use in raising it. But when you're doing design, you don't have to see all of this. But as a practical and as a site person, you ought to understand that this is how it ought to be. You can see. Sometimes you can also go by supporting it at the edge. You can have your upstanding beam, your inverted beam, and be your inverted beam or your drop down beam, as the case may be. Your drop down beam, as the case may be. So that will be that for today.